What we're going to look at now is how can I use this box method to factor a polynomial that has 4 terms. Here's an example, 2x cubed minus x squared plus 6x minus 3. There are no like terms in this polynomial, so there are no terms I can combine. So when we've used the box method in the past to factor trinomials, we've made a box that has 4 squares in it, and we filled in the terms from our expression in the boxes in here. As a reminder, the reason we're doing this is we're trying to find 2 expressions that when we multiply them together give us this as a result. So let's try this process with this 4-term polynomial. So we'll put the 2x cubed here, the minus x squared next, the plus 6x, and the minus 3. I'm going to focus on this first row in my table, and I'm going to ask what could go here? What is a common factor between 2x cubed and negative x squared? Well, both of these have an x squared in them. That's the greatest thing that I can factor out from both of them. Once I filled in one of the things around the outside of the box, the rest of them are really easy to fill in. So x squared times what has to go up here to give me 2x cubed? Well, this must be 2x. X squared times what gives me negative x squared? This must be negative 1. Down here, 2x times what gives me 6x? Looks like that's positive 3. And notice that this last box works out. Positive 3 times negative 1 gives me negative 3. So the correct way to factor this expression is x squared plus 3, reading down the side, times 2x minus 1, reading across the top. And voila, we're done. We can extend this process even further in order to factor an ugly trinomial by turning it into something that has 4 terms. First of all, what do I mean by an ugly trinomial? Well, in this case, the number out in front here is not 1. So this expression is going to be a little bit harder to factor. And remember again, when we factor it, we're breaking it into terms that when we multiply them together, give us this expression. So one thing I notice is 6, 10, and 4 all do have a common factor in them. There's a common factor of 2. I did happen to notice that, but let's say that I didn't notice that right off the top. Let's see what I could do if I didn't happen to notice there was a common factor there. So I'm going to make my box, and I know that the 6x squared term goes here, and the minus 4 term goes here. And these two terms together have to add up to 10x. But there's a lot of different combinations of things that could go in these boxes that add up to 10x. Could be 5x and 5x, 2x and 6x, 12x and negative 2x. Could be a lot of different things. And I would have to do a lot of guessing and checking of what factors go around the outside of this box. Here's a shortcut to show you how to find out what goes into these boxes. Step 1. We're going to multiply a and c in our expression above together. Multiply a and c. So in this case, a is 6 and c is negative 4. That's going to give us negative 24. Step 2 is we're asking what are the factors of that answer, 24 in this case, that add up to b, which in this expression is 10. Factors of negative 24 that add up to 10 are 12 and negative 2. How did 12 and negative 2 help? That tells us what goes in these two boxes. This one is going to be 12x, and this one's going to be negative 2x. Now all I need to do is look around the outside to figure out how to factor what's in these boxes. I'm going to look across this row first. What factors does 6x squared and negative 2x have in common? Well, 2x is a factor in both of them. What goes up here then? 2x times what gives me 6x? That one is 3x. 2x times what gives me negative 2x? That's negative 1. Now, 3x times what gives me 12? Must be that this is 4. 4 times negative 1 is negative 4. All right, this is correctly factored. So my factors are 2x plus 4 and 3x minus 1. I look at this first factor, 2x plus 4, and I notice that 2 and 4 have a common factor. So I can factor a 2 out from there. And now my expression is fully factored.